let's see the question. In the figure shown, what is the equivalent focal length of the combination of thin lenses? And the options are given. This is a previous year's question of NEET 2023. So let's see the figure carefully. This is the figure where N1 is the refractive index of the material of the lens, what is given 1.5, and N2 is the refractive index of the surrounding medium of the lens. That means N2 is the refractive index of the liquid, which is given 1.6. And R1 and R2 are the radius of curvature of the curved surfaces, and R1 and R2 both having values 20 centimeter. So if you see carefully, then you will be able to see that there are basically three lenses. This is lens 1, which is a plano-concave lens. This one is a plano-concave lens, and this is, let's see, lens 2, which is basically a convex lens, and that one is a plano-concave lens, which is, let us, lens 3. Now, before solving that one, let's see which theory is needed to solve that numerical. The general lens maker's formula is 1 by f equal to mu minus 1 by r1 minus 1 by r2, where r1 and r2 are the radius of curvature of the curved surfaces. Now, for convex lens, this formula is 1 by f equal to mu minus 1 by r1 plus 1 by r2. Similarly, for concave lens, this formula is 1 by f equal to minus of mu minus 1 by r1 plus 1 by r2. The equivalent focal length formula 1 by f equivalent is basically 1 by f1 plus 1 by f2 plus 1 by f3. And another thing that we know is generally the focal length is positive for convex lens and the focal length is negative for concave lens. We consider focal length of lens 1 is f1, that for lens 2 is f2, and that for lens 3 is f3. So how we will calculate f1? So 1 by f1 equal to minus of, why minus? Because this is a plano-concave lens. 1.6 minus 1 by 20 plus 1 by infinity. Why infinity, sir? Just because for plane surface the radius of curvature is taken as infinity. So what will be the value? 1 by f1 equal to minus of 0.6 divided by 20. So the value will be minus 6 by 10 into 1 by 20. So the value will be 3 by 5. That will be minus 3 by 100. So the focal length will be minus 100 by 3 centimeter. If you see carefully, then you will be able to see that we can similarly calculate the focal length of lens 3, because this is also a plano-concave lens whose one surface is plane surface and another one is curved surface having value 20 centimeter. So 1 by f3 is the focal length of lens 3, that will also be minus 100 by 3 centimeter. And for the second lens, the focal length will be f2. So 1 by f2 equal to 1.5 minus 1, because this is a convex lens, so no negative sign is there, and its refractive index is 1.5. 1 by 20 plus 1 by 20. So the value will be 0.5 into 2 by 20. So the value will be 5 by 10 into 2 by 20. So 2, 5. So that will be 1 by 20. So f2 is basically 20 centimeter. So now we know the values of focal length of these lenses. Now we just have to use the formula for finding equivalent focal length. So the equivalent focal length will be 1 by f equivalent equal to 1 by f1 plus 1 by f2 plus 1 by f3. That means minus 3 by 100 plus 1 by 20 minus 3 by 100. So 100 will be the LCM, minus 3 plus 5 minus 3. So that will be minus 1 by 100, 1 by f equivalent. Now f equivalent will be minus 100 centimeter. That will be our final answer. Now I will give you one numerical that will be your homework. So you will be able to solve that numerical on the basis of same concept. the question is, this is the figure where r is the radius of curvature of this curved surface, n1 is the refractive index of the material of that length, and n2 is the refractive index of that medium. n1 is given 1.5, n2 is 2, and r is 10 centimeter. Now you have to find what is the power of combination of thin lenses in this figure.